All right, y'all. So in this video, we're going to be looking at how do we find the area of composite shapes. Now that word composite shapes, those words, may not be super familiar to you. But if you think about that word composite, if you know what that means, this stuff we're going to be doing makes a whole lot more sense. So the word composite essentially means that it is composed of two or more things. So it's more than one shape. So essentially we are finding the areas of shapes that have kind of been smashed together. Now, before we can do that, we have to be clear on how to find the areas of basic shapes. So we're going to just fill this out. We should be able to find these. You will also have access to your STAR formula sheet that has all of these on there, but we're just going to go through these. And the ones on the formula sheet are the ones that I'm going to be using. There are other formulas, such as for rectangles or squares, but I'm not going to be going into those. We're just going to use the formulas on the formula sheet. So the area of a rectangle is always the base times the height. Sometimes this is called length times width. We're going to always say base times height in this class. The reason for that is that when we have the area of a rectangle, that directly relates to the area of a triangle, because the area of a triangle is 1/2 of the base times height. Now the area of a square is not on your formula sheet, but it is a nice one to know because it's kind of a shortcut. Area of a square, since a square is technically a type of rectangle, we could still use area equals base times height. But we could also use the formula for the area of a square, which is just the side squared. Since both the sides are the same, it's just that side times itself. Either one works, or you can just forget about squares and treat them all as rectangles. It's up to you. Now the next one we are going to see, just not as much, and that's the area of a trapezoid. A trapezoid, remember, is something that looks like this. We talked about that last semester. And the area of a trapezoid also follows an equation where we have 1/2 of the two bases, base 1 plus base 2, times the height. And the reason that we use the two bases added together is because the trapezoid has typically two different bases. And if we add them together and find the average of the base times the height, which is what this is, that will give us the area. So it's very similar to the area of a rectangle. It's just we have to find the average of the bases first because there's two bases. And the last one, we should be familiar with this. We did it in the last lesson. Area equals pi times the radius squared. That's the area of a circle. Now, all of these are going to be very useful, and they're going to be helping us with our lesson today. A couple other things that we're going to use with a circle. We should also know that the quickest way, and actually here's a shortcut for maybe finding a semicircle or a quarter circle, is just to multiply that by the fraction. Remember, this is like what we did with arc length, with sector area. The area of a half circle is half of the area of a full circle. The area of a fourth of a circle is 1/4 of the area of a circle. So if you have a half circle or a quarter circle in your shape, those are going to help us out, especially in this question here, question 2. Now, we have the areas of our basic shapes. What we're going to do with those is then find the areas of more complicated composite shapes. And there's two different ways that we're going to go about this. We have two different types of composite shapes. The first is when we have two shapes that have been kind of stuck together. Two shapes that have been like connected at their edge. That's what question 2 is like. We have a half circle and we have a rectangle. So those half circle and rectangle, when combined, make a bigger shape. We also have shapes like example 1, where one shape has been taken away from the other shape. It has been removed from the other shape. So if we remove something, we're going to subtract. And if we combine two shapes, we're going to add. And that's all there is to it. So if we can find the areas of both shapes, or 3 shapes or 4 shapes, depending on the problem, we can either add or subtract to figure out the total. So let's take a look at example 1. This one should be pretty straightforward. We have 2 rectangles, and we recall that the area of a rectangle is base times height. So area of the first rectangle, let's say area of 1 equals base times height. And that area is 7 times 2. And those are in meters. So the area of the first shape equals 14 meters squared. And what I'm going to do is I'm going to put that inside the shape. That's going to help us keep everything in the right place. So this is 14 meters squared is the inner rectangle. Now we do the same thing. We find our outer rectangle, and we know that the area of the second shape equals base times height again, because it is still a rectangle. And that tells us the area of the second shape equals 12 times 10, which gives us 120 meters squared. So that's 120 meters squared. All I have to do from here is take 120 meters squared and subtract 14 meters squared, and we get 106 meters squared. And that's our final answer. We have 2 shapes. We took away one shape from the other shape, and we are left with a slightly smaller area. The second example, we're given 2 shapes that are combined together. And whenever we combine 2 or more shapes, we're going to add them together. Now our first shape, the first shape on the left, let's just go with that, is a half circle. And we know that the area of a half circle is half pi r squared. So area of the first shape equals 1/2 times pi radius squared. And it doesn't give us the radius right off the bat, but it does tell us that this side of our our rectangle is 8 feet, which tells us that this side of our half circle is 8 feet. Remember, that's not our radius, that's our diameter. So our radius is 4 feet. I'm going to put that on the other side, actually. Our radius is 4 feet. That's this distance here. So once we have our radius, we can plug that in, find our answer. We get the area, the first one equals 1/2 pi times 4 squared. We continue that through, and we get about 25.1 feet squared. So we're going to fill that into our first shape, 25.1 feet squared. Now we do the same thing on the right side with our second shape. The area of our second shape equals base times height, since this is a rectangle. Area of our second shape equals 12 times 8. And we know 12 times 8 equals 96. This is in feet squared. And we can fill in that to our rectangle. The last thing to do here, I add them together. And I know that 96 plus 25.1 gives us a total area of about 121.1 feet squared. And that is our total answer. So when we're combining shapes, the total should be bigger than either of the two smaller shapes. When we're subtracting shapes, when we're taking one shape from the other, the total should be less than the largest shape. Now here are some steps that are going to keep things straight in your mind. Split the object first into basic shapes. Any shape that we have a formula for is fair game. Typically though, you're going to want to split it into triangles and rectangles and half circles, if possible. Then you find the area of each individual shape and ask yourself, do I add or subtract? Ask yourself, do you add or subtract? Think about the problem. Does it make sense to subtract or does it make sense to add? Once you have your answer, label it, box it, make sure I know it is the final answer. Because otherwise you've got a lot of A's floating around. You've got a lot of A equals this, A equals that. Box the final answer so I know this is your actual final answer. Done, finished, end of story. Okay? Make sure you show your work. Get that partial credit. Add and subtract. Should be good to go.